Welcome to a lesson with Dr. Powell. Let's look at another example of adding up the terms of a geometric sequence. Um, for instance, let's suppose, and let's do this in summation sigma notation. Perhaps we have a geometric sequence and its formula is given by something like 3 times, let's do 4 to the n, and let's take the position and let's go from position 2 up to 7, and let's compute what this is. So using the technique that we had before, kind of what we did is we factor out the first term that we're adding. So you take the first term, but this isn't like the first term of the sequence. This is the first term that we're adding. So the first term that we're adding actually happens at what position? We'll go to the sum to see at position 2. So at n equals 2. So we take that first term and then we multiply that to a fraction. And what this fraction is, we put a 4. Why? Because that's the common ratio. That's kind of like our x that we saw before. Raised to the number of terms that we're adding, minus 1, divided by 4 minus 1. So remember, we have like x to a power minus 1 divided by x minus 1. And that power is precisely the number of terms that we're adding, first term that we're adding. So really, we only have to figure out 2 things to find the sum. 1, we need to find out what the very first term is that we're adding. And 2, we need to find out how many terms we're adding. And then we got it. The first term that we're adding, let's see what it is. It happens at n equals 2. So we plug n equals 2 into this formula that we have for the sequence terms. And so what do we get? Let's suppose that the sequence is labeled as a sub n is equal to 3 times 4 to the n. Let's see. A sub 2 is what we're after. That would be 3 times 4 squared, which would be 3 times 16, which is 48. So the first term amongst the ones that we're adding is 48. Times 4 to that. How many terms do we have? Now notice 2 is just 1 above 1. So if we reduce 2 by 1, 7 by 1, then we can kind of think we're going in a list of numbers from 1 to 6. So that means there's 6 terms. So the number of terms is 6 minus 1 all over 4 minus 1. And then we just compute this out. 48 and divided by this, see, this is 3 right here. So 48 divided by 3 is actually 16. So this is going to be equal to 16 times 4 to the 6th power minus 1. And let's see. 4 to the 6th power is going to be somewhat large. I mean, that's like 2 to the 12, which is, so we have, so see, 2 to the 10th is 1,024. And then you double that a couple times, you can get 4,096. So 4,096 minus, so we have 4,096 minus 1. And then multiply that to 16. And we end up getting 65,520. It's fairly large. But what we did is we added up the terms of this geometric sequence, starting at the term 2, going to the term 7, using this idea, and we got that result. Thanks for watching.